Hello everyone, this is Siddiqur Rahman and welcome to the first lecture of the first week. So let's start with the next slide. By the end of this lecture, you guys will learn combinational logic circuits. Now we need to move into the next slide to know what this lecture covers. So let's start. From this slide, you may know what we are learning or what we have learned from this lecture, such as overview of the combinational logic circuit, block diagram of combinational logic circuit, characteristics of combinational logic circuit, function of combinational logic circuit, classification of combinational logic circuit, and so on. So let's start with the overview. The signals are usually represented by discrete bands of analog levels in digital electronic circuits, or digital electronics instead of continuous ranges represented in analog electronics. The simple electronic representations of Boolean logic functions, large assemblies of logic gates, are typically used to make digital electronic circuits. In digital circuit theory, the circuits thus formed from logic gates are used to generate outputs based on the input logic. Hence, these circuits are called as logic circuits and are classified in two types, such as one is sequential logic circuit and another one is combinational logic circuit. Now, from this slide, we may learn the overview of combinational logic. So let's start. Combining a number of basic logic gates in a larger circuit to produce more complex logical operations is called combinational logic. Using such circuits, logical operations can be performed on any number of inputs whose logic state is either 1 or 0, and this technique is the basis of all digital electronics. Figure 1 representation of a circuit which is represented as combinational logic circuit actually. So let's move into the next slide. Combinational logic circuits can vary in complexity from simple combinations of 2 or 3 standard gates, as we already seen in the previous slide, to circuits containing hundreds of thousands or even millions of gates. It is the ability to combine just a few simple gate circuits, which can be manufactured to microscopic dimension but in almost limitless combinations, that makes digital electronics so powerful. From this slide, we may learn an overview of combinational logic circuit. So let's start. The combinational logic circuits, or you can say time independent logic circuits, in digital circuit theory can be defined as a type of digital logic circuit which is implemented using Boolean circuits, where the output of logic circuit is a pure function of the present inputs only. The combinational logic circuit operation is instantaneous, and these circuits do not have the memory or feedback loops. And these two words needs to be remembered for you guys. And figure 2 represent the concept, or you can say the conceptual figure of combinational logic, whereas left side represents the input logic and the right side represents the output logic, and the middle portion is represented as combinational logic. So next, from this slide we may learn the block diagram of combinational logic circuit, and figure 3 represents a typical block diagram of combinational logic circuit, in where in the left side you may see there are inputs, and in the right side outputs, and number of n inputs are symbolized by n and number of outputs are symbolized by m, and in the middle portion, which is a logic and are more specifically says combinational logic. So what is the characteristics of what we actually learn, or what is the characteristics of this block diagram? Let's see. Number 1, a combinational circuit consists of input variables, n number of input variables, logic gates, which is in the middle portion, and output variables, which is symbolized by m. Next one, for n input variables, there are 2 to the power n possible combinations of binary input values. We already know that. Next one, for each possible input combination, there is one and only one possible output combination. A combinational circuit can be described by m Boolean functions, one for each output variable. Last one, each output function expressed in terms of the input variables. The number of input variables is symbolized by small letter n. So let's move into the next slide. From this slide we may learn some of the characteristics of combinational logic circuit. So let's start. The output of combinational circuit at any instant of time depends only on the levels present at input terminals. Next one, the combinational circuit do not use any memory. This point we have already known from the previous slide. The previous state of input does not have any effect on the present state of the circuit. Last one, a combinational circuit can have an n number of inputs and m number of outputs. Now from this slide we may learn the function of combinational logic circuit. So let's start. The function of combinational logic circuits can be specified in 3 main ways, such as number 1 is truth table, second one is Boolean algebra, third one is logic diagram. So let's start with the truth table. Well, from this slide you may see there is a representation of an example of combinational logic function, truth table. The logic gate function can be defined using its truth table, which consists outputs for all, for all possible combinations of inputs of the logic gate. And I hope you guys are already know about truth table from the previous week, so there is no confusion about this issue. So let's move into the next slide. From this slide you may learn, or you may see, the Boolean expression of the truth table, and figure 5 representation representation of the Boolean expression of the truth table. And this Boolean expression is written from the previous slide truth table. The output of the combinational the output of combinational logic function can be expressed in the form expression using Boolean algebra. From this slide you may see the last way, which is logic gate, and which is also a function of combinational logic circuit. And figure 6 represents the combinational logic circuit using logic gates. The graphical representation of combinational logic functions using logic gates is called as logic diagram. The logic diagram for above discussed logic function truth table and Boolean expression can be realized as shown in the above figure. The combinational logic circuits can also be called as decision-making circuits. Remember these words, as these are designed using individual logic gates. The combinational logic is the process of combining logic gates to process the given two or more inputs such that to generate at least one output based on the logic function of each logic gate. From this slide, you may learn the classification of combinational logic circuit. Combinational logic circuits or circuit is classified into three main types, such as arithmetic and logical function. Second one is data transmission, and third one is code converters. Now start with the arithmetic and logic function, which is also subdivided into four categories, such as adders, subtractors, comparator, and PLDs. And one question may arise in your mind: what is the full form of PLDs? PLD stands for programmable logic device. So we move the second classification of the combinational logic circuit, which is data transmission. And data transmission is also subdivided into four categories, such as multiplexers, demultiplexers, encoders, and decoders. And last one is code converters. Code converters is also subdivided into three categories. Number one is binary. Number two is BCD, which stands for binary coded decimal, and last one is 7 segment. Now from this slide we may know, or we may learn, overview of combinational logic circuit design. So let's start. Combinational logic circuits are designed to produce specific outputs from certain inputs. The combinational logic design can be done using two methods, such as a sum of products, which is in short SOP, and a product of sum, which is in short POS. Combinational logic circuits are generally designed by connecting together or combining the basic logic gates such as NAND, NOR, NOT, and so on. Hence, these logic gates are termed as building blocks. This logic circuit can be a very simple circuit or a very complex circuit, or huge combinational circuit can be designed using only universal logic gates such as NAND and NOR gates. And figure 7 representation represents, or you can say represents, of an example of the combinational logic circuit. Well, from this slide you may learn the design procedure of the combinational logic circuit. So let's start. To design a combinational logic circuit, we need to follow the following procedures, such as first one is the problems is stated, which is verbal description. Second one is specify the number of inputs and required number of outputs. Remember these things. Third one, the input and output variables are assigned letter symbols. Fourth one, construct the truth table to define relationship between inputs and outputs. Next one, the simplified Boolean function for each output is obtained inside of the parentheses using K-map, tabulation method, and Boolean algebra rules. And last one is the logic diagram is drawn. If we design a combinational logic circuit in practically, we need to consider some of the constraints. So let's start. A practical design method would have to consider such constraints as number 1, minimum number of gates, which means how many gates are required to design a combinational logic circuit. Next one, minimum number of inputs to gates. Third one is minimum number of interconnections. Fourth one is minimum propagation time of signal flow through the circuit. In the next lecture, you guys will learn adder, half adder, and full adder. Thank you so much for this lecture, and also thank you for your attention. See you guys in the next lecture. Thank you.